All right, here we're going to go ahead and look at equations of lines. And the first equation we want to look at is something that's called standard form. And standard form of equation is in the form of ax plus or minus, it depends on what it is, by, is equal to c, where a is greater than 0, which means it cannot be negative, and a is not a fraction. Okay, that's a standard form. Now you will see some equations that come up in here or in the textbook that do not follow these, but please understand those are not exactly standard form, but we will work with them as they are. But standard form has rules for a. That means a has to be non-negative and not a fraction. All right, so obviously the first example we're coming across, it is from the textbook. It does not follow that greater than 0 rule, as our a is negative, but we're going to go ahead and work with that. And we're going to go ahead, first of all, we want to see if these 3 points are solutions to this equation. So similar to what we did when we just had one variable and we plugged in a value for x, it was generally x, and we went and see if it was equal to the other side. We're going to do kind of the same idea here, only we have 2 variables. All right, so let's go ahead and look at this. So first thing I want to do, same thing as I did when I did replacement with one variable, I'm going to write out my equation. And anywhere where there's a variable, I'm going to put a set of parentheses. Okay. And the first one I'm going to go ahead is the -4, 0. So in this case, x is -4. So wherever there's a x, I'm going to put -4. This is why I keep the parentheses, so I make sure it is multiplication and not subtraction. And y is 0. Okay, so in this case, 3 times 0 here is 0, so this is going to cancel out. This leaves you with -2 times -4, which is a +8. Is that equal to 8? That's what we want to know. In this case, this is true. So this first ordered pair is a solution for my equation. All right, let's go ahead and look at the next point. I have to do some rewriting here. All right, so I want to know if 2 -4 is a solution to this equation. All right, so in this case now, x is +2, y is -4, and all I want to do is work out where the math is and see if it equals 8. Okay. So negative times a positive is a negative. This is -4. And a negative times a positive is a negative or a -12. In this case, these would need to be added together, giving me -16, which is not equal to +8. So 2 -4 is a false, and it's not a solution to this equation. All right, let's go ahead and look at the last one. Now, last one might scare some of you because it's a fraction. But let's go ahead and look at this. So in this case, x is 1, y is 10/3. And I'm just going to go ahead and plug that in. Now I'm going to do something a little bit different with this one. I know -2 times a +1 is -2. And I'm going to go ahead and write that. The second piece I want to go, okay, well I have 2 fractions. I am multiplying those 2 fractions. So I'm going to go ahead and say, okay, well 3 as a fraction is 3/1. And I'm going to multiply that by 10/3. All right. Now I could go ahead and multiply straight across, or I could realize that I can cancel one numerator for one denominator because they're the same. It is totally up to you. And this gives me 10 over 1, which is the same as 10. Okay. If I hadn't canceled and I multiplied straight across, I end up with 30 over 3, which simplifies to 10. It'd be the same thing. Okay, so now I have a negative 2 plus my 10, and a negative and a positive. I have to subtract, keep a sign a larger number, gives me 8. And 8 here is definitely equal to the 8 over here. So this one is a true statement. It is a solution to this. Now you're probably wondering with the fraction, it's like, why did this work out so well? It's because of the coefficient here for the 3, and we're going to look at that as we go ahead and graph these. All right, so you'll have some where you just need to figure out if there's a solution or not. Don't discount them because they're a fraction. A lot of times they work out and they are a very good solution. All right, so here I go ahead and I have an example of an equation. This equation is in proper standard form because the a is non-negative and not a fraction. In this case, they go ahead and give me values of x or y that I need to find the other value for in order to graph this, right? And when we're looking at something like this table here, you'll often refer to C as a t-table. And that's because you don't necessarily have to draw the lines between everything else, but that part there represents a t. All right. You'll also hear it called an XY table. And that's also valid. So you're going to be doing a lot of these T or XY tables when you're going ahead and graphing these equations. Right now, what we're going to do is we're simply going to go ahead and worry about finding the other value that we have. All right. So this example that we have 3 times x minus 5 times y is equal to 15. Right? And the only value we're given in the first part is 0, that x is 0. So if x is 0 here, that means this is still a y, which means I need to solve for y. Now 0 times anything is 0, so this part is going to cancel out. We're not worried about that. And I have negative 5y is equal to 15. And using our skills for solving equations, I need to get rid of the multiplication by negative 5 by dividing by negative 5 on both sides. And that means y is going to be equal to positive divided by negative is a negative, and 15 divided by 5 is negative 3. So in my table, I'm going to go ahead and fill in a negative 3. All right. Going ahead and working with another value. All right. This time I'm given my y value, and y is going to be equal to 2. In this case, I need to solve for x, so the x is going to stay. So I have 3 times x minus 5 times 2, which is 10, is equal to 15. I'm going to add 10 to both sides. So I have 3x is equal to 25. And I need to divide both sides by 3. And x is equal to 25 over 3. 3 does not divide into 25. How do I know that? Because 2 plus 5 is equal to 7. 7 is not divisible by 3. And in this case, I ended up with a fraction. Icky, but that's what I got. All right, let's go ahead and look at the last point that we have. All right, and I have that x is 5, and I'm solving for y. 3 times 5 is 15, minus 5 times y is equal to 15. Subtract 15 from both sides. And I have negative 5y is equal to, now these two cancel out. Negative 15 and positive 15 cancel out and become 0. And if I recognize this here, I realize that the only way to get 0 is to multiply negative 5 times a 0. But if I don't see that, I can go ahead and divide both sides by negative 5. And 0 in the numerator of a fraction gives me 0. So y is equal to 0. And 0 will go here. All right, now I want to go ahead and graph this. Now, it's nice to have 3 points to go ahead and graph a line. But in this case, this second one here has a fraction, and I am not happy with that. I don't want to graph that. So what I'm going to go ahead and do is I'm going to graph my first and third numbers because they have whole numbers, because that makes me happy. All right, so the first one, I have x is 0, which means from the origin I don't move on my x-axis. And then I have a negative 3, so I need to go down to negative 3, and that's my first point. All right. And I'm going to use my third point, which means I need to go, and my x value is 5, so I need to go over 5. And I'm not moving on my y-axis, which means this is my point right here, which is 5, 0. And this happens to be both my x-intercept here and my y-intercept here. I go ahead and connect my two lines, and that should be my line. Now everybody's going, well, why do I have to have my third checkpoint? Now this is an ugly checkpoint because it has a fraction. But 25 over 3, if I go ahead and make that into a mixed number, all right, what do I get here? So if I divide 3 into 25, okay, if I have 3 times 8, that's 24, okay? So I need to be at a value here at y is equal to positive 2. I need to be at something that is 8 and something on my graph, okay? Let's go ahead and add a couple things here. So 1, 2, 8, and 9. If I go to positive 2, I have 1, 2, 3, 4, 5, 6, 7, 8, and even though it doesn't really show real well because it's a hand graph, I'm close to that 8 and 1/3, which is what this would be as a mixed number. So I can assume that my graph is pretty good. Right? This is a hand graph, so it's not 100% accurate, but I'm pretty close here, so I can assume that my graph is doing okay. That third point should lie on the same line. Let's go ahead and look at one more equation. Now this equation is not in standard form. This is something that's in what we call slope-intercept. And we'll talk about that on another lesson. All right. But basically you see here that my XY table has values only for X and not for Y. That's because X is where my math is at. My X is over here where I actually have to do math. And once I'm done, I've solved for Y. Right? Another thing I want you to notice is that we have a fraction, so we have to work with fractions. My fraction has a denominator of 2, And all my values here are some sort of even number. That's going to be to my advantage. Let's go ahead and look at the first one. So if x is 0, I have 1/2 times 0 minus 2. All right. And anything times 0 is 0. So 0 minus 2 gives me a minus 2 or a negative 2. And I've got my first point. Easy peasy. Let's look at the next one. So I have 1/2, and x is 2. Because I'm working with fractions, I'm going to go ahead, instead of replacing 2 for x, I'm going to replace it as 2 over 1 minus 2. Now if I multiply straight across, I get 2 over 2, which is 1. Or I can cancel it out and get 1 over 1, which is 1. 1 minus 2 is negative 1. And so my y value is negative 1. So going ahead and using a multiple of the denominator or the denominator I have enabled me to come up with a whole number. Let's look at the next one. So I have 1/2. X is 4. I'm going to go ahead and make it 4 over 1 minus 2. Now in this case, when I multiply straight across, I end up with 4 over 2, which is just 2. And 2 minus 2 is equal to 0. And so I get a 0 there. Anytime I go ahead and use the denominator or multiples of the denominator, it allows me to go ahead and get a whole number. So other numbers that would have been good with this would also be negative 2, negative 4, etc. Any even number will allow me to go ahead, cancel out that fraction and make it a whole number, making my life easier and making it easier to graph. Okay, so what I'm going to go ahead and graph all 3 points. So I have 0, so which means I start from the origin, I don't move on the x-axis, and I go down to negative 2. My second point, I start from the origin and I go to 2 and negative 1. And my last point, I go to 4 and I don't go down or up, and these 3 points should line up fairly good, and that gives me my line that I need to draw. Okay, so we'll be practicing with a lot of these. Go ahead and explore this idea, and I'll be here to answer any questions you have, especially with the fractions that are involved in this particular equation. And I'll see you in the next lesson.